Hello everyone, welcome to Math 1350, more on math. Today's exciting lecture topic will be Chapter 6, Section 1. Section 1 deals with the set of rational numbers. Rational numbers. What are rational numbers? Well, the first 5 letters tells us it's a ratio. It's a fraction. Some number over another. This is the numerator on top and the denominator on the bottom, which I'll just call N and D. All right, or symbolically, that R represented the real numbers. W represented the whole numbers. Z represented the integers. Whole numbers starts from 0, goes to infinity. Integers from negative infinity to positive infinity. Only the integers, numbers, no fractions, no decimals or anything. Okay, all those belong in there. Rational numbers, because they're fractions. Another name for fractions is quotient, which is why their symbol is a Q. Rational numbers, or the quotient. Quotients are used for division. Portions, we did parts again, cooking. Ratios, and probabilities. Probabilities, part over total times 100, which is also the same with a percent. So pretty much part over total. And if we want to know what the percentage is, we make it percent. By the 3rd grade, should be able to express whole numbers as fractions, and also to recognize fractions that are equivalent to whole numbers. What does that mean? Well, remember, a fraction is any number a over b. 2 over 5. 3 over 1, which is the same thing as 3. That's what it's saying here. So you can recognize any number as a fraction. So, like 6 can also be 12 divided by 2. 18 divided by 3, or 6 over 1. A fraction actually, a rational expression, actually means this. Given any number, Let's call it n. N is a rational number, it belongs to Q, if there's a number k, where k is not equal to 0, such that n times k over k is a number. Right, so that's how you represent rational numbers. And the reason a lot of people don't like them is they were never really taught what they mean. Actually, another, by grade 4, the student should be able to explain why A over B is equal to A times N over B times N visually. Alright, so to explain that, we have to talk about equivalent fractions. What are equivalent fractions? They're numbers that express or represent the same point on a number line. They're equivalent. Now, what does that mean? Well, which way you show it to kids? We have a diagram. If we cut it into thirds, each one of these is equal to 1/3. That's this much. Well, what if we cut now into, we have our 3 places, cut each of those to half. Now we used to have 3, now we have 6. Each one of these represent 1/6. One third plus 1/3 plus 1/3 equals 3 over 3, which is 1. 1 over 6 plus 1 over 6 is 1 over 6. 1, 2, 3, 4, 5, 6. 6 over 6 is 1. So again, fractions represent parts of a whole. Now, this equals this much. It's the same if we shaded both of those. 1 over 6 plus 1 over 6 equals 2 over 6. So 1 over 3 is equal to 2 over 6. Because they're the same areas. Let's go further. We have the same box. We first start off by cutting them into 3. Cut those in half. That gives us 6. Well, let's cut each one of those in half. Now these are each 1/12. So we took a 1, cut it by 3, you have those. Now if we take each of those and divide them by 2, 3 times 2 is 6. If we take each of those and cut it by 2, 6 times 2 is 12. Now, this same area is represented by these areas. Those 4. So I have 1 over 12 plus 1 over 12 plus 1 over 12. That equals 4 over 12. which is the same thing as 2 over 6 or 1 over 3. So, I mean, you start it that way. Start with this. This is still, that fits on top of that. That fits on top of that. They're all the same size, but now they're cut up into more pieces. Another way you could show how divisibility or fractions work is called a fraction strip. This is used to show equivalent fractions. Similar to one above there. We start off with 1. That's the whole one. If we cut it in half, we got 1/2 here and 1/2 here. So you teach your students 1/2 plus 1/2 is a whole. Okay, what if we take this and make it into 3 even parts? We cut it into 3. This is 1 over the third piece, 3 pieces. This is 1 over 3. This is 1 over 3. Similarly as we did above there, if we take the 1 over 3 and cut those, each of those in half. So 1/2, 1/3 divided by 2 equals 1/6. And I'll show you how that is. Has to do with this rule here. A divided by B divided by a fraction divided by a fraction. Take the top fraction, leave it alone. Take the bottom fraction and flip it and multiply it. So it used to be C over D, now it's D over C. So it's 1 over 3 divided by 2 over 1. Everything's a fraction, remember? So 1 over 3, leave the top one alone, flip the bottom. 1/3 times 1/2, 1 times 1 is 1, 3 times 2 is 6. So that's how that works. Okay, now each of the 6. If we cut those in half, we had 1, 2, 3, 4, 5. If we cut those in half, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all 1/12. Okay, so we can cut those in half. If we take 12 pieces and cut them in half, how many pieces are we going to have? Right, 24. Because for every 1 piece of these, we make 2 pieces. So each of these pieces are 1 over 24. We take 1 over 12 and divide it by 2, which is 2 over 1. 1 over 12 times the flip of the bottom is 1 over 24. And we can keep on going. So everything else now is we just divide the bottom by 2 again. So we can look at this, that 1 over 3 is the same thing as 2 over 6, or 1, 2, 3, 4 over 12, or 1, 2, 3, 4, 5, 6, 7. 8 over 24. So that's a number strip, or a fraction strip, I mean. So that's another way you can show the kids these rules. Which brings us to our first theorem of fractions. Theorem 6.1. The fundamental law of fractions. So this is our beginning rule that makes us all follow fractions. If some number a over b is a fraction, and of course b is not equal to 0, that's what it means by b is a fraction. There is an n, where n does not equal 0, such that a times n over b times n. That's fundamental law. So if I have a fraction and I multiply by the same number, because if you think about it, remember the rule, if I multiply anything times 1, I get the same thing. So 3 times 1 is 3. And anything divided by itself is also 1. So let's look at this. A over b times n over n. What is n over n? That's the same thing as multiplying it by 1. So it means it's not going to change. The only thing it does is change the way it looks, not the way it is. Right, so that's the fundamental law of fractions. Let's define simplest fractions. If a over b has a greatest common divisor, GCD, another name for this is factor. So if a over b has a greatest common factor, n equals 1. Okay, no. How about I say 18 and 36? Well, 18 is 3 times 6. 36 is 6 times 6. Well, that's a common factor, the greatest common divisor. But what is 6 divided by 6? 1. Likewise, the top is made up of 3 times 1. Bottom is 3 times 2. It has a common divisor. So those cancel, it becomes 1. Alright, so let's look at this. What if we had 12 over 42 equals x over 210? How would you find what x is? In order for these things to be equal, for fractions, to be, let's say, compared, you must have a common denominator. The bottom number. So what do we have to do to find out what the bottom number is? The easiest way to do this is find out what times 42 equals 210. So 42 times what equals 210? Well, once we find this, how do we figure out what that is? Divide both sides by 42. Four goes into 25 times. With one left over, 10. So see, 5 times 2 is 10, carry 1 yet. Okay, so it's, the number is 5. So there's a common factor. So once we found this number, we know that 42 times 5 equals 210. Whatever we multiply to the bottom, we have to multiply to the top, because it has to be equal to 1. They have to be able to cancel out. So we had 12. 12 times 5 equals 60. So 12 over 42 is the same thing as 60 over 210. So whenever you have to compare fractions, first find out how much do they have in common. What are their multiples? Once you find that out, then it's all it is just a matter of multiplying that number to the top, and you're done. All right, next one. Let's look at this next part. Equality of fractions. Factor both numerator and denominator That's your first step. Simplify both n and d. If the fractions are the same, then they are equal. No. I've already done. Let's see what that means. 12 over 42. Is that equivalent to 10 over 35? Let's do two ways of doing this. Are they equal? That's what I'm asking. I'm showing you two ways of doing it. Let's follow this way first. So what this thing says is this factor. What is 12 made of? 2 times 6. 2 times 3. So 12 is made up of 2 times 2 times 3. 42. 2 times 21. 21 is 3 times 7. So 2 times 3 times 7. So prime factorize all these. 10 is made up of 2 times 5. 35 is 5 times 7. Just so it's visible. That's what we just did. We did the first step. We factored both the numerator and the denominator. Both numerators. Now, simplify. Remove whatever you have the same. They both have a 2. They both have a 3. So this one simplifies to 2 over 7. They both have a 5. This one, 2 over 7. They're the same, so those two fractions are equivalent. That's one way of doing it. Another way of doing it. If they're equal, then if we cross multiply. Okay, now cross multiply, remember the rule I always like to live by: if you have fractions and equals, multiply by the LCD, which is 42 times 35. And then the 42's cancel, so let me show you. So the LCD is 42 times 35. So multiply the left side by 42 times 35 and the right side by 42 times 35. Once you multiply, reduce. So find the LCD, check. Multiply each term, this term and that term, by the LCD. That's what I just did. Third, reduce. Cancel. 42 cancels with the 42. 35 with the 35. So we're left with 35 times 12, 10 times 42. And then multiply. 35 times 12. 5 times 2 is 10. 6, 7. 6 plus 1 is 7. 5 times 1 is 5. 3 times 1 is 3. So it's 420. 42 times 10 is 42 times 1, and put a 0 behind it. So you just multiply. So yeah, you don't have to go through all this. Just cross multiply. Whenever you have fraction equal to fraction, that's called proportionality. If they're the same, I can cross multiply. Yeah, you can use whatever method you want. And here's the theorem that proves it. The equality of fractions. If A over B and C over D, and if they're fractions, and B and D do not equal 0, if it was 0 is undefined, then they are equivalent if and only if. From now on, I'm going to write if and only if, like that way. They're if and only if A times D equals B times C. So A over B is equal to C over D if and only if A times D is equal to B times C, which is the shortcut which I use. All right. Let's look at inequalities of fractions. Inequalities of fractions. So, if A, B, and C all belong to rational numbers, every number is rational. A over 1, B over 1, C. So, if A, B, or C are all elements of integers, then A over B is greater than C over B. If and only if A is greater than C. Kind of looks like a duh. A, B, and C. You have those. They're all integers. A over B is greater than C over D. They're both B's. So if the denominator is the same, you worry about the top. That's what that says. Same thing with less than. A over B is less than C over D, or C over B, if and only if A is less than C. Another theorem. Actually, that's a theorem also. Denseness of rational numbers. Let's see what this means. Given any two different rational numbers A over B and C over D, there's another rational number between them, between the two. So, given any two different rational numbers, A over B, C over D, then there is another, unless they're equal. If they're not equal, then there's another number, a rational number between there. So if we had 2 and 3, that's 2 over 1, 3 over 1. Is there a number between there? Yeah. 2.5. There's at least one. But let's look another way. Let's look at fractions. 7 over 18 and 1/2. Is there a number between there? Well, we really can't tell right now. What we have to do is we have to get the bottom numbers to be the same. So remember earlier we're looking for the least common denominator. And this is where the chart I showed y'all some time ago. This is your denominators. I got 18 and 2. These are my two denominators. I first factor them. Eighteen is made up of 9 times 2, 3, so it's 2 times 3 times 3. 2 is just made up of 2. Yeah, but everybody has 1, so I don't have to worry about that. What do I need to make them equal? They both have a 2. This one has 2 3s, so this one needs 2 3s. This one doesn't need anything. So if we multiply these two, we get the LCD. 2 times 3 is 18. 9 times 2 is 18. So what we know is 18 is our denominator. That one, whatever's here, multiplies to that. That's the denominator. Whatever's here multiplies to that. So that's a 1. So 7 times 1 is 1, 7. 9 times 1 is 9. Okay, so we see that there's at least one number between them, 8 over 18. Can we find more? Let's see. Let's double the bottom. 18 times 2 is 36. 18 times 2 is 36. Since we multiply the bottom by 2, we have to multiply the top by 2. But remember, it has to be 1. 7 times 2 is 14. 9 times 2 is 18. So between here, we have 15 over 36, 16 over 36, and 17 over 36. If we need more, we keep on going. But there's another way. If I ask you to find a number between there, one number, you could do this. Get the bottom numbers to be the same, whatever the top is, but there you go. But there's no, what's called this Theorem 6.6-5. This is pretty cool. It's pretty lazy, actually. Given two fractions, A over B and C over D, where of course B and D cannot equal 0. And for simplicity here, they have to be greater than 0. It has to be positive. There is another fraction between AB and CD. Because in order to be between there, like 1 is less than 2 is less than 3. So if it's between two numbers, the inequality has to be true. So A over B less than C over D. It gets lined up first. Now, to find the middle number between there, add your numerators. A plus C. B plus D. Bam. There you go. And there's your number between there. I've always thought that was pretty fun. Alright, so that finishes the lecture. Let's look at the homework.